Our next example comes from 2.3. That section is called Solving Radical Equations. So an example of a radical equation again being there's an equal sign, solving meaning we want to actually find the answer. So an example would be if we were asked to solve the square root of x plus 4 equals 10. Square root of x plus 4 equals 10. Now, we have a couple ways of solving this, and I'll start off by solving it algebraically. I think that's the most straightforward and definitely the one that you'll probably be asked the most in this course. The square root is already isolated on one side, so one of our tools in solving for x here will be to square both sides of this equation. So I'm going to square the left side, square the right side. The reason why that's such a handy tool is on the left side now I just have x plus 4. On the right side I have 10 squared, which is 100. Now this is, I hope, a really simple equation for you to solve, and you end up with x equals 96. I check the answer in the original equation to say, does the square root of 96 plus 4 equal 10? So the square root of 100 equals 10, and the answer is yes. So I verified my answer, and there I have a simple radical equation solved. Our second radical equation we want to solve is slightly more complicated, just in that there's another x term on the outside of the radical. I still would start out by doing the same thing. Square both sides of this equation, which leads me to x plus 11 equals x plus 5 squared. Now, when you square x plus 5, please don't just say x squared plus 25. It does mean that you have x plus 5 times x plus 5. And so on the left side I won't do anything just yet, but on the right side I'm going to have x squared plus 5x plus 5x is plus 10x plus 25. You've ended up with a quadratic, which is something you have to solve a whole lot in Math 20, I hope. And so make it equal to 0, meaning bring everything over to one side. So I have to subtract x, which gives me 9x. I have to subtract 11, which gives me 14. So I'm looking to either use the quadratic equation if I'm totally stumped, or ideally I can factor this, hopefully. So I look for two numbers that multiply together to give me 14 and add together to give me 9, and I have 7 and 2. So this one works out particularly nicely. And so, the two possibilities here are x plus 7 equals 0, or x plus 2 equals 0. So x equals negative 7. X equals negative 2. Now if you stop there, you will have missed something important in this question, which is that not necessarily all of these answers are going to work, or both of these answers are going to work. So let me try the first one. Does the square root of negative 7 plus 11 equal negative 7 plus 5? So does the square root of 4 equal negative 2? And the answer is no, because the square root of 4 is 2. So this answer is what they call extraneous. It's not that we made a mistake in coming to that answer. When we squared both sides of the equation, our negative signs got kind of erased in a way, and so that does not actually satisfy the original equation. The second one, if I check it, does the square root of negative 2 plus 11 equal negative 2 plus 5? Is the square root of 9 equal to 3? And the answer is yes. And so we do have one good solution to this radical equation, and that is that the answer is x equals negative 2.